Okay, in the last video we defined this, the definite integral from a to b of f of x dx, to be the signed area between the graph of f of x and the x-axis over the interval from a to b. And we talked a little bit about why we're talking about signed area, and that's because we're not really thinking of this as necessarily being a geometry problem. If the function that I'm integrating is velocity, then the integral that I get is going to represent the displacement of the particle that was traveling. What I want to do in this video is just get some practice calculating signed area and get comfortable with this notion of the concept of signed area. So I want to find the integral from -1 to 2 of, let's do 1 minus x dx. So I'm going to draw a picture of that area. So we're going from -1 to 2 on the x-axis. Now 1 minus x would have a y-intercept of 1 and a slope of -1. So that's just going to be this line that's coming down like so. So I've got that line. I know I can draw in the walls. So I can connect that line to the x-axis at -1 and at 2. And what I want is the signed area between the x-axis and that line. So that's going to give me two triangles where I can see that this one is positive and this one is going to be negative. Now, sometimes when people try to draw in the shape, they don't like having it come in two pieces. They want it to come in one piece. So they'll maybe extend this line down here and then draw across here. That's not correct, because it's the area between f of x and the x-axis. So over the entire region, the top needs to be either the function that we're integrating, which would correspond to this line, or the top has to be the x-axis. The bottom has to either be the x-axis or the function that we're integrating. Okay. So you're allowed to draw in walls to connect the floor and the ceiling. You're not allowed to draw in the floor and the ceiling. Once you've graphed this function, that's either the floor or the ceiling, and the x-axis is either the floor or the ceiling. So you don't get to draw any more floors and ceilings. You just get to draw in the walls that connect them. Okay. So I would calculate this in two pieces. I'm going to have this positive piece and this negative piece. Okay. So for the positive piece, let's see. I'm going to need to know where we cross the x-axis. Looks like that's going to be right here at 1. So this triangle has a base that goes from -1 to 1. That's going to be a base of 2. At -1, the height here would be 1 minus -1, so that would be 2. So the height is also 2. Okay. This triangle, the base goes from 1 to 2, so that's a base of 1. The function value at this point would be 1 minus 2. It would be -1. So that's going to be my signed height. So I'm going to get 1/2 base times height plus 1/2 base times signed height is going to give me 2 minus 1/2, 3/2. So the net signed area that we have here would be 3/2. Okay, I'm going to give you one to try. Let me put the problem up on the board, and then I'm going to have you pause the video and try to draw a picture of this region and calculate the signed area. Okay, so I want the integral from 2 to 3 of 1 plus 2x dx. So pause the video, draw me the region that that represents, and then calculate that signed area. Come back and we'll work through it together so you can check your work. Welcome back. Okay, so on the x-axis, I care about the interval from 2 to 3. The function that I'm integrating, by the way, that has a name. That's called the integrand. That's the function that essentially is my height function. Okay. All right, it's 1 plus 2x. So y equals 1 plus 2x, that has a y-intercept of 1, a slope of 2. So I'll come up 2 over 1, like so. Whoops. I can draw, okay, here, up 2 over 1, and then I play connect the dots. Okay, so that's kind of steep. That's okay. Comes up to here. So I can draw in the walls connecting the curve to the x-axis at 2 and at 3. And so we're looking for, make that wall straight too, we're looking for the area of this region right here. Now, that region is a nice geometric shape. We call that a trapezoid. This is a trapezoid that has a very nice base, and it has a changing height. But I can calculate this height, and then the height just changes in a linear manner between those two heights. So let's see, at 2, the height there would be 1 plus 2 times 2 is 5. At 3, the height there would be 1 plus 2 times 3 is 7. Okay. Now, if I want the area of a trapezoid, and this is all going to be positive area because it's above the x-axis, I've got a couple of options. I can say that the area is just the base times the average height. Now the base, that's the distance between 2 and 3, that's going to just be 1. For the average height, I just take the lowest height here and the biggest height here, so 5 and 7, and I average them. 5 plus 7 over 2. So I'm going to get 1 times 6. That would be a signed area of 6. Okay. Some trapezoids have a fixed height and 2 different bases, and then it's the height times the average base. This sort of had a fixed base and 2 different heights. So it was the base times the average height. If you're not super familiar with trapezoids, and you prefer, you could break it up this way. And you could say, okay, I'm getting a rectangle plus a triangle. Now, for both of those shapes, I'm going to count the area as positive because all of that is above the x-axis. And then I can say this has a base of 1 and this has a base of 1. The height here would be 5. The height of the triangle is the vertical distance between 5 and 7, so that would be 2. And so then I can say I'm going to get 1 times 5 is the area of the rectangle, plus 1/2 of 1 times 2. That's going to be 5 plus 1. That's going to give me 6. So either way, I'm going to get 6 as the signed area for this. So if you like the formula for a trapezoid, you're welcome to use it. If you prefer, you can always break your trapezoids up into a combination of rectangles and triangles. Okay, I'm going to put one more problem up on the board. And we'll do this problem when we come back in the next video. But between now and then, I want you to see if you can figure it out. This is a challenging problem. Okay. I want you to see if you can find for me the integral from -2 to 0 of the square root of 4 minus x squared dx. If you can draw the picture, you can probably get it. If you don't see the picture, this is a really tough problem. But I'm going to tell you, this gives me a nice geometric shape, so I can calculate this without knowing any calculus other than that this is defined to mean the signed area between this curve and the x-axis. I can get this just using formulas from geometry. So think about that a little bit, see if you can figure it out. We'll work through it together in the next video.